Okay, so good afternoon, everyone. I'm Serena Goodrich of LPI, and I'd like to welcome you to this first session in a three-part series on how to become part of NASA's planetary sample science community, which is sponsored by NASA and LPI. Today, we'll be having two presentations about NASA's Astromaterials collections, followed by about half an hour for questions and answers. If you have questions for either of the speakers, feel free to enter them into the chat at any time. And keep in mind that we are not going to be monitoring raised hands. So if you do have a question, you need to use the chat. After both of the presentations are over, we will be reading the questions from the chat to the speakers and also alternating between questions in the chat and questions that were submitted ahead of time online, those that are relevant to today's topics. So our first speaker is Dr. Jemma Davidson, who will be talking about NASA's Astromaterials Acquisition and Curation Office at Johnson Space Center. Dr. Davidson is the branch chief for the Astromaterials Acquisition and Curation Office at Johnson Space Center and was also recently appointed as the new Astromaterials Curator. As Astromaterials Curator, she is responsible for protecting the scientific integrity of NASA's 9 astromaterials collections and distributing these samples to the global community for scientific research. Jemma got her PhD in planetary science at the Open University in 2009, and prior to joining NASA earlier this year, she was a research scientist whose research involved the study of a large array of astromaterials, including those from the moon, Mars, asteroids, comets, and extinct stars. So, ready for you, Jemma.
Thank you for the introduction, Serena. So I'll go ahead and share my slides with y'all. Okay, can you see my slides?
Yes.
Okay, perfect. Okay, thank you, everybody. I am indeed Dr. Jemma Davidson. My pronouns are she, her. I'm really excited to talk to you today. I'm very excited about this series of workshops. We at the Astromaterials Acquisition and Curation Office, we're really passionate about astromaterials, but above all, we're really passionate and excited about getting these samples into all of your hands so you can go do all of your amazing research. In the office, most of our curators are PhD level scientists who come from research backgrounds. So, we know what it is to perform all this research on these amazing samples, and it's our job to make sure that we get you the samples that you need to do your research. So really happy that I'm able to talk to you today about what we have over at the Johnson Space Center. So before I get started, I just want to let you know, and for the folks online who aren't familiar with who we are and what we do, our office at JSC is responsible for curating all of NASA's extraterrestrial samples. We currently have 9 collections. We are governed by this document, a NASA procedural requirement, or NPR 7100.5, charges us within the NASA Center that manages all the astromaterials collections and curation facilities, and it lays out our responsibilities to you and the broader community. And this pertains to all current and future astromaterials collections. So when you hear about Artemis samples coming back in the near future, they'll be coming to us here at the Johnson Space Center. So the first thing I'll tell anybody is, if you want to learn more about what we do, go to our website. So it's linked here and on nearly all of their slides in this talk. But this is really your first port of call for where you can learn about the different sample collections that we have, how you can get samples, and there's lots of additional information on the website. And this is broadly the structure I'm going to use to run you through what we have and how you can get those samples. And I have a special treat for you today, because I brought our Apollo curator, Ryan Ziegler, with me, and he's going to talk to you about how to write an amazing request to make sure that you have your best shot at getting samples. So over at the Johnson Space Center, we have these 9 current collections, but you may or may not be aware that we also do a lot of other works in preparation for samples coming back. We call these emerging collections. So Artemis is going to bring back samples from the moon. We also have the sample receiving project that MSR is normally going to bring back samples in the near future from Mars. And we are a partner with the Japanese Space Agency in the Martian Moons Exploration mission, which will bring back samples from one of Mars's moons, Phobos. Additionally, we also do advanced curation research, and this is research and other endeavors that enhance our current collections and also help pave the way for the emerging collections so that we're ready to receive those samples when they come back. And you see here, like this pithy little diagram shows that everything we've learned by curating the current collections can feed into the emerging collections, but also the things that we learn or the technologies we develop for the safe curation and handling of future collections can also feed back into the collections that we already have. So we're never static, we're always trying to improve and find new ways to best serve the broader community. Okay, so I'm really excited to run you through the 9 collections that we currently have. We'll go in chronological order. So this is just the overview, but everything started with Apollo in 1969 when those samples started coming back. Since then, we've built collection upon collection, and to the point where any of you who followed the news will have seen that we brought back samples from a carbonaceous asteroid last year through the OSIRIS-REx mission. So I'm going to talk about all these collections. So lunar, meteorite, cosmic dust, microparticle impacts, Genesis, Stardust, Hayabusa 2, and OSIRIS-REx. And this will be a whistle-stop tour because we really could talk about any one of these collections for an entire hour. So instead, we're just going to give you the kind of Cliff's Notes version and point you in the direction where you can go to find more information about each of these different collections and who to talk to. Because I know that is really the first sticking point for people. It's like, well, where do I go and who do I talk to find out the information that I need? So that's really broadly what we're aiming to do for you today. So NASA Apollo, this is where everything started in terms of extraterrestrial sample return for the US and why curation got started at the Johnson Space Center. So 6 different Apollo missions collected almost 400 kilograms of rock, soil, and cores. It's a phenomenal amount of material between 1969 and the early 70s. That accounts for over 2,000 separate samples from 6 different collection sites. Some people don't know this, but the collection also includes samples returned by the Soviet lunar missions. And I would tell you that if you want to learn more about any of this, to check out the website, but also talk with our Apollo sample curator, Dr. Ryan Ziegler. He's the expert on that collection. And in terms of scientific investigations that have been done on samples from Apollo, really it's again, this is could be its own talk. They're almost unlimited. The sample analysis work that was done on the rocks returned by Apollo has completely revolutionized our understanding of the moon's origin and its evolution, its relationship with Earth and the terrestrial planets, and even solar system processes. So there is really very few limitations to what you could learn about not only the moon but the broader solar system by looking at samples from this collection. So if you want to learn more about what we have in Apollo, so I encourage you to go to this website here. And I've broken out some of the interesting parts of this that you may want to focus on, but I really encourage you, if you want samples from Apollo, go troll through this and read everything. Ryan is going to talk to you a little bit more about this, so I'll just give you the whistle-stop tour. But you can learn about the history of the collection. The sample request information is really detailed, and it's not just requests for samples for scientific study. We also have education and public display samples. So the request information for that is also in there. The sample catalog, Ryan's going to take you through that for Apollo, I believe. So he'll show you how that works. But also, this is something that really helped me in my research when I studied Apollo samples. It's the Lunar Sample Compendium. So if any of you folks are getting started looking working on specific Apollo samples, please check out the sample compendium. It isn't completely up to date, but it has decades worth of scientific information of everything that has been done on specific samples so far. So if there's one in particular you're interested, you can go download that pack of information from the compendium and you can get a really good feel for everything that has been done on individual samples. And that's going to be really key for you to figure out which samples you should request. So I highly recommend you spend time doing that. You can get lost in it because there's so much information, but it's a lot of fun, but it's also extremely valuable. Okay, so the next collection that came along in the late 70s was the Antarctic meteorite collection. So these are meteorites that are recovered in Antarctica by the Antarctic Search for Meteorites, ANSMET. If you want to learn more about that program, you want to support that program, I encourage you to go to this link here. You can learn more about that there. And this is a unique collection that we have in that it is part of a 3-agency agreement. So this is a joint agreement between us folks at NASA, also the Smithsonian, and the National Science Foundation, NSF. So NSF provides the logistical support to get the teams down to Antarctica, and while NASA curates all the non-iron meteorites that come back, the Smithsonian curates the irons and pallasites, and it classifies all of the samples. The folks there at the Smithsonian do a great job classifying a lot of samples that come back on nominally an annual cadence. Things have been not quite annual since the pandemic, but this is a continually growing collection because there are teams that are still going down there to collect samples. If you want to learn more about the collection, check out the website, but also you can talk to our interim meteorite curator, Dr. Francis McCubbin. You can see inset here about the meteorites in the Antarctic meteorite collection cover a vast array of different planetary bodies. So in addition to Apollo, you can also get lunar samples for the lunar meteorites in this collection. We also have lots of samples from various different types of asteroids. So if your heart is intent on studying chondrites, I encourage you to check out the Antarctic meteorite collection. We have a really broad array of samples. And in terms of the scientific investigations that have been done and can be done, there's really a huge scope. The limits at this point are really your imagination. So I wouldn't worry about what you can or can't do. Just write a good request. So again, go to the website. So you'll notice as you move through the different collections that they look similar, but the information is laid out in different ways. So there's quite a large background information section on Antarctic meteorite. We also have information in there about how samples have been prepared and how they can be prepared. So if you're not quite sure how you want, what form you need your sample to be in, or what you want it to be in, or what can be done in terms of preparation, there's information there on the website. There's also a lot of information about sample requests, and have a bit more on the next slide for that. But one of the things I wanted to point out for Antarctic meteorites is we have these compendia, which are very useful. It's essentially data mining has been done for you. So if you are new to planetary science, you're new to extraterrestrial sample analysis, go check out the Martian meteorite, the lunar meteorite, and the HED compendiums. Like the Apollo compendiums, they are compilations of all work that has been done up to a certain point. They're not up to date currently, but they do have decades worth of information collated into one place. So I encourage you to check that out. So I'm not going to dig into this for each of the collections because there's so much, but I wanted to point out that if you go into the website, choose the different sections, go into sample requests, allocations, and loans, you see here, it is laid out step by step. So please read through all of that information. There's a phenomenal amount of information on the website. I'm planning a big update soon, so we'll make sure that everything is absolutely up to date. But it tells you how to prepare a proposal, how to submit, what the review process is, and what are your responsibilities when you get those samples. So again, please check out the website. So the next collection is Cosmic Dust. So this is a collection that came on board in the 80s. Again, it's another one that is a continually growing collection. So these are small particles that originate from asteroids and comets. Originally, we started with collecting cosmic dust in the stratosphere. We used collector plates on NASA aircraft, but also recently accessioned some micrometeorite collections, the South Pole water well collection and the South Pole air filter collections. So we have stuff that's been collected on the ground as well as in the atmosphere. In the near term, we do plan to continue targeting stratospheric collections towards meteoroid showers. So, in terms of cosmic dust, in addition to having dust on collector plates that are just collected at opportune times when we could fly collector plates, we also make sure to target events like the passage of Comet Temple Tuttle, Comet Griggs Skellerup. So, if your heart is set on studying cometary material, I encourage you, like, those are the places you should look for that information or those samples to request. And in terms of the scientific investigations that have been done to date, so understanding the nature of the flux of extraterrestrial material to the Earth is really a key part of some of these investigations. Studies of organics, a lot of these interplanetary dust particles, we call them, are very pristine, they're very fragile, and they maintain very like primitive characteristics from when they formed, when they were aggregated. And so that's why you find a lot of organics in there and also a lot of pre-solar grains. So if you are somebody who is interested in studying pre-solar grains, whether that's to learn about tracing parent body processes, or if you're interested in stellar nucleus synthesis, so I encourage you to not only look at the cosmic dust collection, but also to look at the meteorite collection, because we have some very pristine chondrites in there with high pre-solar grain abundances. We also have pre-solar grains present in the stardust collection. So whatever your interest is and whatever you are working on, or whatever scientific question is that you're trying to answer, never feel like you're only limited to requesting samples from one collection. There's probably going to be multiple collections that can help you. So in the same way, like if you're interested in learning about the moon, you'll want to look at meteorite and Apollo. If you're interested in pre-solar grains or pristine material, please consider cosmic dust in addition to meteorite and even stardust. So the cosmic dust curator is currently Mike Zelinsky. Mike will pop up a few times in this talk. He is our curator of several collections. Currently, this lab is undergoing review, so we're currently closed, although it will open up in the near future. And if you plan to request for samples from this, I encourage you to sign up for the Astromaterials newsletter. We make our big announcements there, and so we'll make sure that once we're up and running again, that it will be announced and you'll have that information. Okay. So again, if you go to the website, there's some significant background information in cosmic dust about the collection, also how they're collected, which can be really important, especially when you're looking at fragments or IDPs, particles that we send you. If you ask for them to not be pre-characterized, because that's so you can be allocated samples, and nominally we try to make sure that you're getting extraterrestrial material. However, these collector plates are flown in the atmosphere where there's a bunch of other things flying around, so you might find that I don't know, say you find a grain with a huge cadmium peak when you throw it in the SEM, it's probably paint that came off the aircraft or something else. So we encourage you to also not only understand your samples, but to understand the context of how they were collected, because that can help you figure out if what you're looking at is something else, if it's terrestrial. So you can go get more information about the different collection descriptions as well. So please go read about the South Pole Water Well collections, the SPA, all that information is in there. And also how you request samples. Again, go to the requesting samples page, follow the information. Your best bet for getting samples is always following the rules, and Ryan's going to talk to you more about that. And also look at the sample catalogs. So I know it can be daunting and not knowing where to start, but for any of these collections, go look at the sample catalog, see what's available, and that'll help inform you make your decisions. And at the end of the day, if you're still not sure, reach out to the curators, because nobody understands the collections better than the individual curators, and they are a resource that is available to you. Okay, next one, microparticle impacts. Again, this is another collection that's curated by Mike Zelinsky. And a lot of people don't know that we curate a variety of spacecraft and spacecraft components that have been impacted by natural and man-made microparticulates. So If that is something that you're interested in, or it can help you answer your scientific questions, these are things that are available to you for request. So currently we have the Genesis and Stardust sample return capsules in the collection, pieces of Surveyor 3, the long duration exposure facility, which you can see here on the right, the Solar Maximum satellite, the European recoverable carrier, and parts of the Mir space station and the Hubble Space Telescope. And all of these materials are preserved for scientific investigations. So if you are interested in doing studies of environmental effects in unique environments, or with a focus on micrometeoroid impacts, this could be a collection that you may want to consider requesting to. It is one of the collections that we receive the fewest number of requests from. I think that's just the nature of the collection, but I want to make sure that you all know that this is available and something that you can request samples from. So please check out the website. Again, it's a different collection. It works a little bit differently to the others, but all the information that you need to know what we have and how to request it is available on the website. And again, I just highlighted here to go check out the specific sample request information and also the sample catalogs. Okay, so this one's an exciting one because it just had its 20th anniversary of Earth return. So Genesis, there was a solar wind mission, returned samples back in 2004. They collected solar wind at the Sun L1 location for 28 months. So they had, you see Judy Alton here on the right. She's our Genesis curator. She's holding the collector array. Unfortunately, the landing was off nominal, which is a really nice way of saying things were fragmented upon impact with the Utah desert. And because of the nature of the fragmenting of those samples, there's significant terrestrial contamination. However, that did lead to significant development of cleaning methods here at JSC. We clean things very, very well now. And ultimately, most of the science objectives were still actually achieved. It was a really, really fantastic example of how people come together and solve difficult problems and ultimately overcame this, what could have been somewhat disastrous, but ultimately was a very successful experience. So I would encourage you, if you're interested in learning more about solar wind, maybe you're coming at this from a different background, you've never studied samples before, more theoretical, there might be experiments that you can do with these samples that help answer your scientific questions. So this is the Genesis website. So again, check out the sample request information and forms. I wanted to point out here that in addition to the sample catalog, you can also find a lot of information about the different collector materials. So for Genesis, they use different types of collection medium to collect solar wind because there's different things that you can measure in the different collection mediums. And if you want to know what we have, like sapphire or some other some other collection medium, please go check out all of the information on the website, and I think that'll be the best starting point for you all. And there's a lot of history. Judy Alton, the Genesis curator, does a really great job of collating the science that has been done on the samples to date as well. And if you sign up for our newsletter, you'll find out when they are going to host future Genesis workshops, because there's a good way to get into Genesis. It was a small community of science investigators. They're still actively 20 years on having annual workshops where they all get together and talk about the latest science. So if you are interested in getting into these studying solar wind in these materials, that could be a great entry point. And again, at the end of the day, if you have questions, contact Judy. So the next sample collection is Stardust. So this came back a couple of years after Genesis. It was a really exciting time for sample return. And they went and collected, well, they flew the Stardust spacecraft through the coma of Comet Wild 2. So they collected material from the comet. And they also then, when they were away from the comet, collected material in space, so interstellar dust. The collection medium was aerogel. And currently, so aerogel can degrade over time. And currently, one of the things that we're doing in curation is we're removing all of the different particle tracks from aerogel to mitigate any potential degradation of the samples over time. So you can see that here. This is it. This is what we call a keystone. So this is a track, an impact track, and these are all being cut out of the aerogel. This is the collector plate. And this is some of the, we also, in addition to the aerogel inside these collector plates, the strips that are between them are aluminium foil, and there's craters in there. So if you're interested in microparticle impacts, you'd want to look at the microparticle impact collection, but you could also look at the aluminium foil samples from the Stardust collection. So like I said before, there's usually multiple collections that can help you answer your scientific questions. And so work that has been done on samples from Stardust have helped us understand the formation and evolution of comets, early solar system migrations. So this mission really changed the thinking about the migration of material that formed closer in the inner solar system all the way out to the outer solar system. It was really pivotal in changing the way people think about migration of material in the early solar system. Again, I mentioned this before, but also there's pre-solar grains in this collection. So if that is something you're interested in, this is a good place to look. Again, this is another collection that is curated by Mike Zelensky. And then similar to the other collections, you can find all the sample request information, the information about deadlines. But I wanted to point out to you, because these samples were collected in aerogel, which is a medium we didn't use in the other collections, there is information in here specific to aerogel contamination control, understanding what effects that material could have had on the sample. So please go check that information out on the website as well. And then if you have questions, contact Mike. But the website also helpfully breaks out particles based on whether it's cometary dust or interstellar dust. So you don't have to figure that out. That information is there on the website for you. Okay, so then now we're moving into the era of partnership with the Japanese Exploration Space Agency, JAXA. So their Hayabusa mission brought back samples from a silica-rich asteroid, Itokawa, in 2012, which seems like yesterday to me, but I also realize is now over a decade away. But this was the first mission to return sample from an asteroid, and it was really a phenomenal achievement. There was an error with the sample mechanism during deployment, but phenomenally still were able to return some samples. So they're very fine particles, smaller than anticipated, and they do require advanced handling methods. And so one of the things I would encourage you to also look out for is, if you are interested in getting involved in the community and analyzing these small samples, look for the small particle handling workshop, which is run out of LPI. It is a phenomenal workshop. Serena can tell you more about it. I think it's annual, maybe it's biannual, but it always has rave reviews, very positive reviews. And at that workshop, you can learn how to handle small samples like this, because part of the process for you to get samples is to improve that you know how to handle them, right? So you can see, actually, I'll point out here, you can see that these are some of the fine particles in our collection. So they're really, really small. So they do require advanced sample handling. But because this returned samples from an asteroid, it improved our understanding of asteroidal bodies, but it also taught us more about just the general origin evolution of silica-rich bodies in the solar system. And if that's something that you're interested in, you could analyze these samples or request these samples. But I also encourage you to consider also looking for asteroid-derived meteorites, which are in the Antarctic meteorite collection. So if you're interested in studying asteroidal material, you can look at the meteorite collection and then our various asteroidal collections, including Hayabusa, Hayabusa 2, and OSIRIS-REx. Okay, so again, same kind of deal. Here's where you'll find the sample request information and the forms. And you can also see information about how to prepare samples, different methods for preparing samples. And it's a really useful collection of information, and the state of the Hayabusa samples that we have. So what do they look like? And are they going to be useful for your purposes? So if you want to study asteroids, but you need large samples, we suggest that your first port of call be the Antarctic meteorite collection, because we have so many meteorites that derive from various different types of asteroids in that collection. And you can also see what samples are available or have been allocated. And if you have questions, feel free to reach out to Mike. So there was a little bit of lull in sample return for almost a decade, but in 2020, the Hayabusa 2 mission, so the successor to Hayabusa, another JAXA mission, returned samples from the first carbonaceous asteroid. So this went to asteroid Ryugu, brought back samples. Because the mission was able to collect more samples than the Hayabusa mission, our portion over the Johnson Space Center, which you can request, is larger, and we have much larger particles. And while the particles from the Hayabusa collection are individual small tiny pieces, these are larger ones that may require may require subdivision depending on what it is that you're looking to do and what kind of request you're looking to put in. And the work that has been done in this lab has really been leading the way in terms of advancing small particle handling here at the Johnson Space Center. So we're really lucky that the curator of that collection, Christopher Sneed, is a phenomenal small particle handler. He has been helping lead the small particle workshops with LPI. He's really fantastic, innovative mind. So we have been making sure to put that to good use and to be improving the ways that we handle samples, but also making sure that we get that information out to the community so you all have the opportunity to benefit from that experience and you can all learn how to handle these samples for your own purposes. And also, this is a thing I kind of touched on earlier in the talk, but the work that we do in the different labs benefits all of the collections at JSC. So things that have been developed now in Hayabusa 2 have implications for handling of small particles in all of the collections, including cosmic dust, Hayabusa, and OSIRIS-REx. But also, we try to make sure we get that information out to the community so that you can benefit from the things that we learn. We're here to serve. And I encourage you, if you find yourself at any of the major conferences like LPSC and Meteoritical Society, to look up the curation sessions, because we'll inevitably have somebody there talking about some of the latest stuff that we've been doing. And hopefully that will be of help to you. So a lot of the scientific investigations that have been done on these samples have been to understand the origin and evolution of carbon-rich bodies, but really you're only limited by your imagination. You can learn a lot about solar system evolution by looking at these materials because they largely remain unaltered since they formed in the earliest days of solar system history. So go check out the website. There's all the information you need there about sample requests, the documents, the forms. We have some information about the sample collection, the samples that are available for request. And failing that, if the information isn't there, ask Dr. Christopher Sneed. And also, I'm also always happy to hear about things that people would like added, like what more information can we put there to help you. These are pretty thorough. So if there's something missing, please let the curators know. Okay. On to the last and newest of the collections. So this was NASA's first asteroid sample return mission, OSIRIS-REx. Returned samples from carbonaceous asteroid Bennu last year, just in September. We just had the first year anniversary of the successful Earth return. And this is a really beautiful picture on the right of the sample head. You see all of that gray, it's actually very black material. This has been, the light levels have been changed, but just this very gorgeous, rich, carbonaceous material from asteroid Bennu. We returned about 120 grams, which is a lot of material. It was twice the amount required to meet mission requirements. So it's the newest collection that we have. We're still in the mission analysis phase. That runs for nominally another year. Recently, though, while we are busy allocating samples to the sample analysis team, also recently solicited the first call for sample requests. So the next call will nominally be in the spring. Please sign up for the Astromaterials newsletter. I am going to talk about that in a couple of slides' time, but This isn't a shameless plug. This is really the place for you to get delivered directly to your inbox updates of the different collections. So if you are champing at the bit to get samples from Asteroid Bennu, that'll be where we announce the next date for the call for samples. And similar to the Hayabusa 2 collection, but not entirely the same. A lot of the scientific investigations in there are about understanding the origin and evolution of carbon-rich bodies. So really, there's a phenomenal amount of information that you could learn from these samples. I encourage you to submit in the next round. Our curator of this collection is Nicole Lennon. She's been doing a phenomenal job moving us through the mission phase and into the community request phase of this collection. So the sample request forms and the information you need are on the website. You can look at the sample catalog. Now this is constantly evolving. This is, again, the samples only came back about a year ago. So that sample catalog is just going to keep growing and growing and growing. So I encourage you to come back and check when the next request round is open. There'll be a lot more information in there. So please don't feel like everything that is in there is what will only ever be in there, because it's not the case. It is going to improve and expand. And so it's something that you should check regularly. And a particular jewel of this collection is the Ava images you see marked down here. These are phenomenally high resolution images of the samples. They're incredible. And it's not just the ooh factor, because they are incredible and they're fun to look at, but they can also help you when you want to request samples, because you can actually see what the samples look like and if they work for your purposes. So please check out the website, and if you still have questions, contact the curator, Dr. Nicole Lennon. Okay, so I think I said this enough times in the talk, but I'll just reiterate it one more time. Please, if you want to learn more, go check out the website. There's a phenomenal amount of information there. And failing that, refer back to these slides. They will be available online, so you can get the information about who to go contact. But additionally, I want to talk just a little bit about this. Ryan's going to cover this more, but there's a couple of things I want to talk about, and in terms of cadence of requests and also the Astromaterials newsletter before I turn things over to Ryan. So who can get samples? So I saw the questions that some people pre-submitted. Well, any scientist can request NASA Astromaterials for scientific study. It's not just limited to US-based researchers. Any scientist. So if you are in Europe, I think that was one of the questions, you are welcome to request samples. You may be able to tell from my accent, came from that direction. And before I was in the US, I requested samples for many of these collections, helped me do my research. So the sample requests, the way that they're dealt with is they're reviewed by an appropriate panel of the Astromaterials Allocation Review Board. So this is peer review board. A group of experts will review, and not within curation, but within the broader community, will review the sample requests and make recommendations. That's also reviewed by the collections curator, and then they make a recommendation that comes to me as the head curator, and then goes up to the chief scientist for curation and SMD at headquarters, is Dr. Kathleen van der Kayden, and then things get signed off. So of the 9 different collections that we have currently, lunar meteorites and OSIRIS-REx are reviewed twice a year with request deadlines approximately 6 months apart. Those deadlines are announced in the Astromaterials newsletter, so please sign up for that, and then you'll have that information as soon as it is made available to the broader community. And then the other 6 collections, these are the smaller collections with generally fewer requests. So they are on a rolling deadline. You can submit requests to those at any time. I did mention before that Cosmic Dust is currently on pause, but for any of the others, you could submit a request today. So yeah, I think let's see what's next. Okay, so there's the last thing I want to talk about. Again, I've plugged this a few times, but I found that repetition is key. So please go sign up for the Astromaterials newsletter to learn more and stay informed. So you can see here, this is linked from the website, and you can subscribe down at the bottom. And you can also unsubscribe, although I'm not sure that any of you would ever want to unsubscribe, because why would you want to miss out on all this fantastic information? But the Astromaterials newsletter announces new samples. So any new sample that we get is announced in the newsletter. So everybody in the community has a fair shot at getting samples. There's no hoarding of information. Everybody gets to learn about new samples through the newsletter. We also announced reclassifications. So this is particularly important for the meteorite collection, but I encourage you to pay attention to all of the collections. But occasionally, sample classifications change over time. So, different meteorite groups get regrouped. We realize that samples that have been classified as one thing are different, and those reclassifications get announced in the newsletter. And that can have really important implications for the interpretation of your data. So I do encourage you to keep an eye on things like that. It's worth, before, if you have a sample and your data looks a little bit interesting and not quite what you're expecting, maybe go check and see if it's been reclassified and if it's not actually something else, because that's happened to me a few times. We also announced the request dates in here and any changes in curated duties. This is really helpful if you have a question and you want to know who to send it to. There's not a lot of turnover in curation. However, we do bring on new curation personnel every now and again. There'll be the announcements about that in there. Recently, the most recent issue was announced that I would be taking over from our former Astromaterials curator, Francis McCubbin. That's how that news was communicated to the broader community. And then any other updates as we see fit, and links to things like the Astromat database, that is a different kettle of fish, but also a really, really important resource for anybody who wants to study samples. In addition to looking at the compendia, you can go to the Astromaterials database and find all of the data that has been published on the samples that you may wish to request. Okay, so just to summarize, at JSC, we are home to NASA's 9 current astromaterials collections. We provide samples to support the study of astromaterials to qualified researchers across the globe. And it's our task to preserve the scientific integrity of the samples for generations to come, so that those samples are available for people who aren't in the field yet, maybe haven't even been born yet, and to be analyzed with technologies that haven't been developed or invented yet. Our website should always be your first port of call for information. There's a lot of information on there. I encourage you to troll through it. Please sign up for the Astromaterials newsletter. It'll help you stay up to date with changes and announcements. And if you still have questions, contact the collection curator. Thank you.